In number 9, we'll start by factoring each of the denominators and observing that each denominator is equal to 0 if x is either 3 or 4. So the domain for this equation is that x may not be either 3 or 4. Once we've done this, we can multiply by the least common denominator, which is x minus 3 times x minus 4. Once we've done this, we can cancel common factors in the numerators and denominators. In the first multiplication, x minus 3 and x minus 4 divide out or cancel. In the second multiplication, x minus 3's divide out or cancel. And in the third, x minus 4's divide out or cancel. The first multiplication has a result now of 5, the second of 2 times x minus 4, and the third of 5 times x minus 3. Now we can use the distributive property of multiplication over subtraction to rewrite each of the expressions on the right side, combine like terms, add 23 to both sides, and then finally divide both sides by 7 to get x is equal to 4. However, you will notice that the restrictions, or the domain, say that x may not be 3 or 4. So this is an extraneous solution, which means that there is no solution for this equation. Be sure that you specify and box your final answer that there is no solution. It's not enough to just say extraneous solution. We need to make sure that you are stating that there is no solution for this equation. In number 10, we'll begin by factoring each denominator and observing that a denominator will equal 0 if x is either 1 or negative 2. So x may not be 1 or negative 2. This is our domain. Now we're going to multiply by the least common denominator, which is x minus 1 times x plus 2, and canceling or dividing out common factors in numerators and denominators for each multiplication. This will leave the first multiplication as x times x plus 2, and the second as 3 times x minus 1, and the third as 9. Now we're going to use the distributive property of multiplication over addition and over subtraction to rewrite the left side of the equation. Be careful when distributing a negative. Let's combine like terms. So we get x squared minus x plus 3 is equal to 9. In order to factor and solve, we need to have a 0 on one side. So subtracting 9, x squared minus x minus 6 is equal to 0. From this point, we can factor into x minus 3 times x plus 2 is equal to 0. That means that either x minus 3 is equal to 0 or x plus 2 is equal to 0. Solving each of the two equations, we get two solutions, x equals 3 or x equals negative 2. However, you'll notice that x equals negative 2 is an extraneous solution since the domain is x may not equal 1 or negative 2. This means that x equals 3 is the solution and the only solution to this equation. Be sure that you box your final answer. In number 11, we'll begin by factoring each denominator and observing that the one or both of the denominators are equal to 0 if w is equal to 0 or equal to 2, so w may not equal 0 or 2. That's the domain. Now we're going to multiply by the least common denominator, which is w times w minus 2. Now we can cancel or divide out common factors in numerators and denominators for each of the multiplications. W minus 2 cancels or divides out in the first multiplication. Both factors divide out in the second, and none divide out in the third. This leaves the result of the first multiplication as 1, and the second as 2. Excuse me, the first multiplication is 1 times w, the second is 2, and then on the right side we have w times w minus 2. We need to multiply the right side, so we get w squared minus 2w. And now if we're going to solve by factoring, we need to move all terms to the right side of the equation. I would move to the right side because that makes the leading term have a positive coefficient. So I'm going to do two things. I'm going to subtract w from both sides and then add 2 to both sides, and that gives us 0 equals w squared minus 3w plus 2. After that, we can factor, and that leaves us with w minus 2 times w minus 1 is equal to 0. And that means that either w minus 2 is equal to 0 or w minus 1 is equal to 0. Solving each of those individual equations, we get w is equal to 2 or w is equal to 1. You will notice that w equals 2 is an extraneous solution since the domain is w may not equal 0 or 2. That means that w equals 1 is the only solution. Make sure that you box your final answer so that it is clear that you understand that w equals 1 is the only solution. In number 12, we're going to begin by factoring each of the denominators. And once each denominator is factored, it will be clear that when each factor in the denominator is equal to 0, it'll cause the denominator to equal 0. So therefore, u may not equal 0 or negative 1. Now we're going to multiply by the least common denominator, which is 6 times u plus 1, or if you want to leave it in factored form, 2 times 3 times u plus 1. Now we can. In number 12, we're going to begin by factoring each of the denominators, and then observing that one or both of the denominators will equal 0 if u is equal to either 0 or negative 1. So u may not equal 0 or negative 1. And that is the domain. Next, we're going to multiply by the least common denominator, which is 6 times u plus 1, or if you want to leave it in factored form, 2 times 3 times u plus 1. This may make it easier to cancel common factors, which is our next step. The first multiplication, factors of 2 and factors of u will cancel. In the second multiplication, factors of u plus 1 will cancel. In the third, factors of 3, factors of u, and factors of u plus 1 will cancel. That leaves the result of the first multiplication as 3 times u plus 1, the result of the second as 6 times u, and the result of the third as 2. Distributing, we get 3u plus 3 minus 6u is equal to 2. Combining like terms, negative 3u plus 3 is equal to 2. Now subtracting 3 from both sides, 2 minus 3 is negative 1, and dividing by 3, we get u is equal to 1/3. Since the domain is u may not equal 0 or negative 1, u equals 1/3 is not an extraneous solution, which means it is a valid solution, so I'm going to box that as my final answer. In number 13, we're going to begin by factoring any denominators, but I observe that no factoring is necessary. Next, I'm going to observe that each of the denominators may be equal to 0 if n is equal to 4 or 3. So n may not equal 4 or 3. Next, we're going to multiply each term by the least common denominator, which is n minus 4 times n minus 3. Next, we can cancel common factors in each of the multiplications. N minus 4 in the first multiplication, n minus 3 in the second one, and in the third multiplication, no canceling. That leaves the result of the first multiplication as 4 times n minus 3, the second as 3 times n minus 4, and the third as n minus 4 times n minus 3. Now we have to do each of these multiplications. to simplify both sides. And now we're going to move all terms to the right side of the equation. But before we do that, let's simplify just a bit. On the left side, we're left with just n. 4n minus 3n is n. Negative 12 plus 12 is 0. So now we have n squared minus 7n plus 12 is equal to n. We need a 0 on one side if we're to solve by factoring. So subtracting n from both sides and factoring, we get n minus 2 times n minus 6 is equal to 0, which means that either n minus 2 is equal to 0 or n minus 6 is equal to 0. So n is equal to 2 or n is equal to 6. Neither one of those are extraneous solutions, so there are two solutions in this solution set. Both 2 and 6 are valid solutions.